Welcome back to Endurance Sweat. This is the third part in a four-part video series on Zwift fitness tracking. In this video, we'll look at metrics for training score and status. Zwift reports two metrics, training score and status, but there's actually a third metric that we'll have to examine. So first, training score. That's your long-term training load, the 42-day exponential moving average. And while Zwift calls it training score, Training Peaks calls it chronic training load, or CTL. The next one is your short-term training load. It's your 7-day or 1-week exponential moving average of your stress points. Training Peaks calls it your acute training load. Zwift doesn't directly report this measure, but it's needed in order to determine your status. Training Peaks calls status training stress balance, or TSB. And that's the difference between your short-term training load minus your long-term training load. Now, I've used the term exponential moving average. At the end of the video, I'll get into explaining exactly how the exponential moving average is calculated and differentiate it from simple moving average, which you're probably already familiar with. Okay, let's get on with it. So, long-term training load, CTL, what Zwift calls training score. People often colloquially call it a measure of fitness. I like to think of it as how much aerobic load you can sustainably carry. I also think of it as the base from which you can build on. So for example, if you've been putting in weeks and weeks of training load at 200 stress points, why, you can build on that to increase your fitness by picking up your training score from 200, say, to 210 or even 220. Let's see what that might look like on a graph. In this chart, the vertical bars represent the stress points earned each day, and the line represents the 42-day exponential moving average. You can see that on some days, the stress points significantly exceed the exponential moving average. Other days they're lower, and other days they're zero, but all of them are included in that 42-day exponential moving average. And that's your measure of fitness, your base. If the line is moving in an upward direction, that signifies an increasing level of fitness. On the other hand, if it moves down, that means you may be losing fitness. Zwift presents you with your training score in 3 different locations. First off, when you finish a ride, you'll get the progress report, and your training score will be presented in the bottom right-hand corner. On the companion app homepage, your training score is prominently shown at the top left-hand corner. And if you click on the fitness trends bar, you'll be presented with a number of graphs. The second one down is your training score. Now, what about your short-term training load? What Training Peaks calls acute training load. It's your 7-day stress point exponential moving average. It's a measure of the fatigue that you're putting on your body due to recent activities. And you compare it to your long-term training load, what Zwift calls training score, what Training Peaks calls chronic training load, to determine your status. Note that short-term training load is not reported anywhere on Zwift, but Zwift internally calculates it to determine your status. So here's a chart of the short-term training load, or acute training load. Again, the vertical bars represent the stress points that you've accumulated on any one day, and the line represents the 7-day exponential moving average of your stress points. You'll notice that this line is a lot more jagged, because it represents a moving average over a much shorter duration. And now we'll compare the long-term exponential moving average to the short-term exponential moving average to give us status. Status is the difference between the short-term training load, or acute training load, and your long-term training load, or what Zwift calls your training score. So looking at the graph on the right, the top squiggly line represents the 7-day exponential moving average of the short-term training load. The next line, the smooth gray line, represents the 42-day exponential moving average of your stress points, or long-term training load, what Zwift calls training score. And then the line at the bottom is your status, the difference between the short-term training load and the long-term training load. Now, something to be aware of. While Zwift calculates status by taking the short-term training load and subtracting the long-term training load, Training Peaks flips those about. So for the Training Peaks training stress balance, they would calculate that by taking the chronic training load and subtracting the acute training load. Just something to confuse us. Depending on that difference between short-term and long-term training load, Zwift places your status into one of 4 categories. There's fresh, active and ready for challenges. Productive, consistently challenging yourself and recovering well. Overreaching, training heavily, or maybe should really say training too heavily. And detraining, lots of fitness due to reduced training. And then there's a 5th category that's not shown on the chart. If you haven't done enough rides to accumulate data to calculate long-term and short-term training score, while your status will be recorded as ready, new to training. You can see your current status on the progress report after you've finished a ride on the home screen of the companion app. And if you click on that fitness trends on the top of the companion app, you can scroll over and see a graph of your status for 4 weeks, 3 months, 6 years, and even up to 1 year. So let's recap. Your training score, or your long-term training load, what Training Peaks calls your chronic training load, or CTL, is your exponential moving average of your stress points for 42 days. Is a measure of your fitness, what I like to think of as my base from which I can add training load to improve my fitness. Short-term training load, or what Training Peaks calls acute training load, is the 7-day exponential moving average of your stress points. Many refer to it as your fatigue. And then status, what Training Peaks calls training stress balance, is the difference between your short-term training load and your chronic training load. And it's a measure of your freshness or form. Just a quick reminder that only training score and status are reported on Zwift, but not acute training load. Now, before I end this video, I want to remind you that I'm going to go over the calculation for exponential moving average in detail in just a few moments. So this was part 3 of the 4-part series. So today we went over training score and status. And in the next video, I'll be going over training plans. Now, if you're interested, I'm going to explain in detail how exponential moving average is calculated. Otherwise, I'll say so long till next time, train hard and have fun. So here's the formula for exponential moving average. So for an n-day exponential moving average, so 7-day or 42-day, for example, it's equal to today's points times a smoothing factor called alpha. And to that, you add yesterday's exponential moving average times 1 minus alpha. And alpha, the smoothing factor, is equal to 1 over the number of days. So 1 over 7, 1 over 42, for example. So here's a comparison between simple moving average and exponential moving average. As we know, for the simple moving average, we add all the values in the period and then divide by the number of values. And each value in that period contributes the same amount to the average. So if there were 10 values, then each would contribute 10%. Now, it's different for the exponential moving average. A reminder, the equation for EMA is EMA equals the current value times alpha plus the previous EMA times 1 minus alpha, where alpha equals 1 over the number of days. Now, in the EMA calculation, the current value contributes the value times alpha. So if alpha is 1 over 10, it contributes 10% to the EMA result. But the preceding values contributes to the result at a diminishing rate. And that diminishes by 1 over n% for each preceding value. So if you're doing an EMA for 10 days, for example, the preceding values contribute 10% less for each preceding day. So a takeaway for the EMA is that the most recent values contribute more heavily to the average than the later values. And SMA and EMA calculations are really fundamentally different. The SMA calculation is for a discrete number of values in a period of time. So for example, the preceding 10 values divided by 10. But when we're talking about a 10-day EMA, we're really talking about the smoothing factor. The smoothing factor alpha equaling 1 over 10. Or for a 7-day EMA, we're talking about a smoothing factor of 1 over 7. But the values that we consider in that formula, by virtue of the fact that we're always looking at the previous day's EMA, extends beyond the 7-day, 10-day, or 42-day period. It's a bit tricky to get your head around this. I know it took me some reflection to figure it out for myself, but I think I've got it right now. Maybe looking at a couple of examples might help. Here we're going to calculate the exponential moving average for the day that I've highlighted in yellow. And we're calculating it for 7 days. So alpha equals 1 over 7, or 0.143. So the EMA will equal 3 times alpha, so 3 times 0.143, plus the EMA for the previous day, which was 5.65, times 1 minus 0.143, and we get a result of 5.27. Let's look at another example. Here we're going to calculate the SMA and the EMA for the last line in that table. And it's a 7-day period. So for the SMA, again, we sum up all of those values for the 7 days and we divide it by 7, and we get a result of 5.71. For the EMA, we're going to take today's value and multiply it by alpha, 0.143. And to that, we're going to add the product of yesterday's EMA, which was 5.57, times 1 minus 0.143. And we get a result of 5.2. Now remember, I was saying that in the EMA calculation, today's value has a higher contribution to the EMA result. And that's reflected in the values that we're getting in this calculation. Whereas the simple moving average gave us a result of 5.7. The exponential moving average gave us a result of 5.2. So now let's look at the exponential moving average for the acute training load, which is a 7-day EMA with a smoothing factor of 1 over 7, and for the chronic training load, which is the 42-day EMA with a smoothing factor of 1 over 42. So the real difference is the smoothing factor. They both look at the same stream of data. So the acute training load having a much higher smoothing factor, the most recent stress point values have a much higher impact on the EMA result. Let's have a look at that with some curves. And we can see the influence on the smoothing factor for the acute training load, the curve shown in blue, how it starts high and then tails off really quickly. So the most recent values have a much higher influence on the result. With the 42-day EMA, the smoothing factor curve is much more even. So all the data points contribute more evenly. And now we're looking at the 7-day exponential moving average for the stress points for acute and chronic training load. The line representing the acute training load is very jagged, whereas the line representing the chronic training load, using the 42-day exponential moving average, is much smoother. Okay, I've tried to explain exponential moving average, showing you the equation that's used, trying to explain the smoothing factors, showing you a couple of examples of how EMA is calculated, and comparing the acute training load EMA smoothing factor of 1 over 7 with the chronic training load EMA with the smoothing factor of 1 over 42. So I hope my explanation of exponential moving average has been clear enough to give you an understanding of how it's calculated and maybe give you a better appreciation of Zwift's training score and Zwift's status metrics. And if this video has been helpful, why give it a thumbs up, subscribe to the channel, and click on that notification bell so you'll be notified when I post my next video in this series. And please post your comments. I really like to know what you thought of the video and whether you think I've got it right, or if there's points that you'd like me to clarify. I really value receiving your comments. Until then, train hard and let's have fun.